For the integral calculus, there are two types of integral calculus, the definite and indefinite integral. For the indefinite integral, it says that if the derivative of the given function is f of x dx, then the indefinite integral is defined as, so this is the symbol, integral of f of x dx is equal to the capital F of x plus c. So here, this is the symbol for the integral, and then the integrand, the content of the integral is f of x dx, and then the result upon removing the derivative is actually the antiderivative. And upon integration, we always have to introduce a constant of integration, which is c. Now, the idea here is that the integral is just simply reverse of the derivative, wherein the objective here is we have to remove the derivative in order to determine the function, but it is no longer the function, but we call it as the antiderivative. So then, for the definite integral, we have this time there is a given value or given limit, wherein again we have that if the derivative of the function f of x is f of x dx, then we can define that in a closed interval from a to b. Then the definite integral is the integral of f of x dx from a to b is now equal to the antiderivative f of x from a to b. So in order to evaluate this, just simply substitute the b, which is the upper, minus a, which is the lower limit. For the basic theorems in integral calculus, we will consider that the u, v, w here are integral function of x. Then, the derivative of u is now equal to u plus c because we have to remove the derivative. For a constant k, derivative of u, since constant has no derivative, so we can express as coefficient, and then just evaluate the du, so this is simply k times the u, and then upon integration plus c. If we have an integral of several terms, so integral of du plus dv minus dw, just evaluate each term. So this is simply integral of du plus integral of dv minus integral of dw. Then we have u plus v minus w, and then upon integration plus c. And these are the first two fundamental methods of integration. We have the power integral and the general power integral. So the only difference here is that for the power integral, we consider a simple x raised to a power n, whereas for the general power integral, we can consider any variable other than x or simply just any quantity, wherein the integral of x to the n dx, just simply add 1 to the exponent and then divided by n plus 1. And then upon integration, this is plus c. For the general power integral, or this is also known as the substitution, wherein it has the same concept that if there will be a quantity u raised to n, the derivative of that u should be given. And then this is the integral, just simply u raised to n plus 1 over n plus 1 upon integration plus c. For the first example, we have to evaluate the given integral here. For number 1, the integral of x cubed minus 12x squared plus 5x minus 20 times derivative of x. So this is only an example of power integral where as a as start of an example, this can also be expressed as integral of x cubed dx. And then minus 12 x squared dx plus 5 x dx minus 20 integral of dx. So this is by means of power integral. Just add 1 to the exponent, so it becomes x to the 4th because 3 plus 1 over 4. And then minus 12 times for the square, 2 plus 1, and that will be cubed. Plus 5 times, this is understood raised to 1, so x plus 1, rather 1 plus 1, and that will be 2 over 2 minus 20, and this is the first basic theorem. integral of dx is simply an x. And then simplifying, we have x to the 4th over 4. And then we can divide the 12 by 3. That will be 4. 5 over 2. And then minus 20. And then finally, we have 1/4 x to the 4th minus 4x cubed plus 5x squared minus 20x plus c. Another example is, for number 2, we have x to the 5th plus 12x cubed minus 10x plus 10 derivative of x. So we can evaluate right away. No need to show the solution by step. So this is just simply by power integral. So then this is simply x to the 5th plus 1. That will be x to the 6 over 6. And then we have 3 plus 1. That will be 4 over 4. So 12 divided by 4. That will be 3. Raised to 1 plus 1, that will be squared, divided by 2. So 10 over 2, that will be 5. And then 10 times integral of dx, and that will be x. So this is already our final answer, which is 1 over 6, x to the 6 plus 3x to the 4th minus 5x squared plus 10x plus c. Now, for example number 3, this is an example of the general power integral, or simply by substitution, wherein we can consider the quantity 3x plus 4 raised to cube as our u. So this is the pattern, u to the n, and then this should be the du. If we will check, if u is equal to 3x plus 4, then we have the derivative of u is 3dx. So it so happened that the only given here is dx. So we can input 3 together with correctional factor of 1/3. So then this is now the same concept as power integral. Therefore, this is simply 3x plus 4 raised to 3 plus 1. That will be 4 over 4. Then we have 1/3 times 1/4. That will be 1/12. And then multiplied by the quantity 3x plus 4 raised to the 4th. And then upon integration plus c.